First thing we'll talk about here is how to word the conclusions for our confidence intervals, making sure that we include all of the important elements, and then we'll end with finding critical z-scores based on confidence levels. So wording conclusions, as we found in that last video, we're going to focus on that 95% confidence interval that we found, which we found was a 0.4604 up to 0.4996. which would translate to a 46.04% to 49.96%. So that's giving us our lower bound and upper bound for the confidence interval. What we're going to go ahead and do in the wording below here is we're going to round that. So we're going to round to 46% to 50% for our wording below. Again, in terms of calculation, you should show all your work and include these values of your confidence interval. But then when you get to the sentence, if you want to round to whole numbers, that would be okay. So all of this was based on a sample proportion of 0.48. So we started with that sample proportion, built the confidence interval, and then we get these range of values. And the idea is that whatever our population proportion is, it should be within that interval with 95% confidence. So, some things that we want to talk about when we make our conclusions. One thing that we're going to mention is our level of confidence. In fact, I usually just start the sentence saying like with 95% confidence or with blah blah percent confidence, and then going from there. Then we need, and the order doesn't matter of these, but we just need to hit these 3 points when we're making our sentences. The range of values, so you want to include the actual interval that we found, which when you state this, since we're only doing confidence intervals with proportions, it'll be something like some lower percent to whatever your upper percent is. And then this is the tricky part of what do those percentages represent? And the idea is that our true population proportion should be between those values. So the proportion that we want to describe here is we want a description of the population proportion. Description of what P would represent. So the idea being, so our original sample, that 0.48 came from 2,500 HR professionals. Then in terms of our description, we'd want to talk about all HR professionals, which is a common word that relates to population. You want to look at everyone. Some things to be careful of here is when you make your description, never mention the sample. So you don't want to mention your sample proportion. That was part of our calculation and it was really important. But in terms of the conclusion, we're trying to make this conclusion that's only about population data. So the conclusion's all about the population. So we don't want to mention anything about our sample proportion or sample size because those are part of the work, but they're not part of the conclusion. So we're going to do here, I know I kind of wrote out the solution in the previous video for this one, but let's just talk about why these sentences don't work and which one does. So this first one says 48% of all HR professionals use social networking sites to research job applicants. So this 48%, that's our sample proportion. That came from the 2,500, and they're trying to say that's true for all HR professionals. So they're basically trying to say the sample proportion that we took is equal to the population proportion, which we do not know that. We don't have that information. You wouldn't know that unless you collected the population data. So we can't just say that that sample proportion is the population proportion. So that sentence does not work. This one basically says the same thing. It takes that 48% and relates it to all. The only thing it adds in now is that it is probably true. So it's trying to get this idea of percent confidence coming through, and this is kind of like over 50% confidence by saying it's probably true. But we still can't do that. We still can't just take that 48% and say that it is the population proportion, even if we're adding this kind of looser wording of it might be true. It's probably true. With part C, we don't know exactly what proportion of all HR professionals use social networking sites. So now they're saying we don't know what P is, which is true. And then now we're getting a range of values, which is awesome. We want that. So that's hitting part 2 up above there. But what we want to be careful of is that while they're saying we don't know what our population proportion is, but we know it's between those 2 values. And that's basically stating 100% confidence. But what we want to be careful of, which I stated at the beginning of that last video, it is possible to take a random sample and have it be an outlier. It's unlikely, but it could happen. And when we randomly sample outliers, that's going to cause the interval to not capture the true population proportion. So we'll never be 100% confident in our interval. So we can't do this. Nope. Does not work. This next one is basically the same sentence, but what they throw in is that it's probably between those 2 values. And that's getting better, but in terms of our calculation that we did, that's too vague. We can do better than just saying it's probably between there. So that's also a no. This next one is awesome. It hits all of the pieces. It says we are 95% confident. So now it's saying how sure we are. So instead of saying we know, which would mean 100% confidence, or it's probably, which just kind of means like over 50%, we're 95% confident. And then between those 2 values, which is awesome. And then this is where we see our wording for the population proportion. All HR professionals use social networking sites to research job applicants. So this is what we want. That's perfect. So that's the type of sentence that we want to make. You can see they don't mention the 48% anywhere in there, and that's because that's our sample proportion. So that's done with. It also doesn't mention the 2,500 people that we surveyed because we were done with that. It just relates confidence level, the interval that we found, to a description of our population proportion. With the wording of the questions that we look at, they'll often give you a structure for how to phrase your true population proportion. So we'll look at some examples with that. All right, so in terms of making confidence intervals, we'll have some sample proportion that we start with, plus or minus, and then we have this z star value. And then we'll have a square root p hat times q hat over n. So pretty much all of this will be given to us, but I wouldn't even say it's a tricky part because it'll end up being fairly easy once we go through these. But there's this value that we'll need to plug in based on the confidence level that we're using. And it'll change based on confidence level. So like when we did 95% confidence, we used 1.96 right there, but if we switch to 99% confidence, that'll change. But what's nice is that we only really need to find these once, meaning that z-score that we found, or that z-star that we found for 95% confidence, that came from our standard normal curve. That curve wasn't based on our sample data at all. It's doing its own thing. So we just took that standard normal curve, put 95% in the middle, and saw that the cutoff had to be 1.96. That's not going to change example to example. Meaning, whenever I ask you for 95% confidence, you're plugging in 1.96 right there, every single time. So what we're going to do here is I'll show you how to find these. These are commonly used confidence levels. It's possible to see others, so that's where I'll show you how to find these. But really, after this video, you don't need to find them again unless if you're asked to find like a 96% confidence interval, then you'll have to go and find it. But basically we'll get these values, and then you can just use this sheet to look them up again and again, and that'll be it. For the z-star values, I'm going to go ahead and round to 4 decimal places just to be consistent with what we've been doing through the term. However, out there in the real world, a lot of resources take these to 3 decimal places. Ours will be a little more accurate. It shouldn't cause any drastic changes in solutions, but I just want to put that out there. I'm going to go to 4 decimal places so that you don't get confused with different rounding rules, we'll just stay consistent. But if you round these to 3 decimal places to match other resources, that's completely fine too. All right, so actually let's jump down to 95% confidence just because we've already done that one. So just as a refresher of what we did is all of these, so z-scores mean we're always going to use the standard normal curve. So for each of these, I'm going to be using my standard normal distribution, centered at 0, standard deviation of 1. Actually, I'll just go ahead and draw that for each of these. And then what I want to do is take that confidence level and have that be the area in between the 2 cutoffs. So the idea is that I want to figure out how far above and below the center I need to go so that, like for 80% confidence, I want to go below and above 0, and I'll make these as symmetric as I can by hand, but I want to do this such that 80% is in the middle. And then for 90% confidence, similar idea, I'll just have a little more area in between. And then this value over here on the right, that cutoff is your z-star value. For 95% confidence, so 0.95 in the middle, and that'll be z-star on the right. 99% confidence, we'll have 99% in the middle, so z-star on the right there. So what we did for 95% confidence in that previous video is that with GeoGebra, I basically want to find this cutoff. We know this area under the curve. However, what we talked about was in GeoGebra, we can't just center an area. So we need to get a little creative with how we find this cutoff. So what we can do is use the tail areas. So the side math that I just kind of talked through quickly in the last video but didn't show was thinking about, okay, we have 100% of our data, take out the 95%, and that'll leave us with this 5%. So with that, that's giving me the area in the 2 tails. So I know it's in between, and then overall in the 2 tails, I have 5%, and then I just need to cut that in half. So really I have this 2.5% left over. So I know I have 0.025 out here on the left-hand side, 0.025 out here on the right-hand side. So what I did in GeoGebra was I went in and I looked at where's this cutoff such that 0.025 is to the right-hand side. So if we go back to GeoGebra, that's what I had set up here. So I did a right side and then set the area to 0.025, which gave me the cutoff of 1.96. So that's where that 1.96 came from. So 95% confidence intervals will always use 1.96. So what if we had 99% confidence? So again, similar idea of take 99% out of that 100%. So we're left over with this 1% in the 2 tails. Cut that in half. So we're going to have 0.5% in each tail. So what I'm going to do to find that z-score is that lines up with this spot that has 0.005 to the right-hand side. So I'm going to just change that area to 0.005, and that's a 2.5758. So if we need a 99% confidence interval, that'll be our critical z-score. If we're finding 90% confidence, we'll take 90% out of 100%, so we'll have 10% left over, cut that in half, and that'll leave 5% in each tail. So we'll have 5% over here, 5% over there. So for our z-star value, we want to see where's this cutoff such that 5% is to the right-hand side. So if we go to GeoGebra and just change that to a 0.05, that's a 1.6449. So that'll be our critical z-score for any 90% confidence interval. And then for an 80% confidence interval, take 80% of 100%, so I'll leave us with 20%, cut that in half. So we're going to have 10% in each tail. So we want to see what's this cutoff such that 10% of the data is to the right-hand side. So in GeoGebra, change that to a 0.1, and that'll be a 1.2816. So based on your confidence level, you can find this z-score by putting that confidence percentage in the middle, and then you just have to do the side math to figure out what's in the tail, and you can find this cutoff by plugging in that area to the right. You could also think of this in terms of area to the left. You just have to do some addition, and I'll even show this with the z-star for the 80%. I could have plugged in, okay, to the left-hand side, there's 80% and 10%. So overall, there's 90% of data to this left-hand side. So what we could have done in GeoGebra is gone left-sided and then area of 0.9 to get that same answer out. So you can think of it in terms of left or right. It's just with the left, be sure you add on the tail. A common mistake would be to plug in 0.8 there, because that feels correct because that's our confidence level, but you have the confidence level plus the tail area. So that would give you an incorrect solution there, but by adding on that tail, you get the right answer. So write down these z-scores so that you can easily refer to them through the other problems. Otherwise, at least for these, you won't have to calculate them again. You can just refer to this sheet and grab them for when you're using the formula. But again, if you have something like 96% confidence, you can go through this process to find that critical z-score.